Okay, welcome everybody. Hey, good question?
So the example that just came out said OB2 is on 30th April. Is that true or not?
That is true. Yeah.
Oh, okay. So everyone's OB2 on 30th.
Yeah, that's correct. So it's absolute last day of exams, I think. So plus minus. Your summer holidays don't start quite as soon, but you do spread things out a bit. So okay. So hopefully everybody has started on milestone 2. What I asked that today is everybody started on milestone 2? Put up your hand if you started on milestone 2. Okay, some of you I'm hoping are just like not into participation, and otherwise you're making me nervous. So what we're going to talk about today are two things. First is we've already talked about how to visualize your map, how to create widgets using ece2. So ece2 is all you need to sort of visualize your map, right? It gives you nice attribute and primitive drawing functions. It also gives you a few widgets, okay? Buttons, it gives you a drop-down, like a combo box, which is like select one of these options and pop up boxes and so on. So a few UI widgets that you can set up really easily using ece2 code, right? We made it so that you know, 1 or 2 function calls will get everything set up. But GTK is a really big library. It has a huge number of widgets. Widgets are these like UI elements that you can kind of interact with. So we're not going to put wrappers around all of those, but you might want to use some of them. You don't have to, so you can complete milestone 2 without using any direct GTK code at all. But in case you want to, the first part of this tutorial is about how to directly interact with GTK, the graphics library that's underneath ece2. And the second part is about how to figure out where your code is fast and slow, and that's useful for trying to make your milestone 2 responsive. Okay, so start with the first part. So we're going to talk about how to modify the GUI more, kind of at a deeper level than what we did in tutorial 6. Now let's see if I can make this advance. Okay, I already told you this. The window layout, so where are the buttons and so on, where's the drawing area, what we call the main canvas, is specified in a file that we've given to you. It's in your libstreetmap resources directory, and it's called main.ui. So you can just use that file. You don't have to change it at all if you don't want to. But if you don't like the look of the UI, you can modify it. It's actually a text file. It's in XML format, so you can actually open it up and like edit it with a text editor, but that's going to be a bit painful. So more commonly what you do to edit this file is you use a GUI editor, okay? And GTK, its GUI editor or GUI builder is called glade, okay? So glade is a program that basically knows how to edit this XML file that represents the user interface, and it gives you some, links to documentation and things like that that makes it a bit easier to modify it. Okay, so I'm going to type this command in a minute, but basically this is how you start that program so that you can edit your main.ui. What kind of things can we do in this? We could move around things, so I'll show you that first, just change the layout of the UI. We can also add additional GTK widgets, like elements that ece2 doesn't expose to you. If ece2 exposed it to you already, then it's actually easier to do it through ece2. It'll be less code. But again, we only expose a few widgets, and the rest, if you'd like to use them, you have to go straight to GTK. Okay, so this is going to be pretty demo intensive. I'm going to do a couple things. I'm going to open up this glade editor, and I'm going to change the name of the program, and I'm also going to move around some of the elements. So we'll start with some basic things. Okay, so let me bring up a window here. Okay, so the first thing I'm going to do is I was actually messing around with this before. So I'm going to go back to my pristine okay, so I want to basically get the main.ui that you guys would have. Okay, I want to start off with that. Okay, so I just did a checkout to get the actual main UI that's in Git that we gave you. And now I'm going back to the mapper. Okay, so I'm starting this glade program. And I need to tell it the path to my UI layout, which is in libstreetmap/resources. So remember, Source is source code, resources is like data that my mapper needs. Main.ui is not source code, it's data, so it's in resources. I'm gonna open it up. Okay, so this is the Glade UI editor that I just started. Let me hide these meeting controls. Okay, I'll make this a little bit bigger. Okay, so there are a few different windows in here. So over on the left is the widget view, okay? And it's like a tree view, it's hierarchical. So and here in the middle is like a layout view that's showing where are my widgets relative to each other, what will my UI look like? And over on the right is like a properties view. So whatever widget I've clicked on is showing me properties of it. Okay, so what I've clicked on right now is the main window. Okay, main window is the name that we gave to like the whole window, right? The whole user interface. And in this view, in the middle, you can see there's a green border and it says main window. So it's just showing you that's the whole thing, okay? And what properties are there? Well, here's a property. The title is EasyGL application example. Everybody with me so far? Okay, so, okay, now if I click down here, so I've already expanded this one, so let me unexpand it. Okay, so I click on this arrow, I see what's inside main window. Inside main window is a different widget called outer grid. Okay, well, that's the type. It's a type, well, actually, its type is a GTK grid, and the name that we gave it is outer grid. Okay, so what is a grid? Well, let's click on it, and you see the whole UI layout in the middle turns green again. So this grid is actually still covering everything. A grid in GTK is a way of organizing UI elements spatially. It basically, you're putting like a grid or a mesh on top of your UI. So you have rows and columns and you can stick things in them. So it's kind of like you have a spreadsheet. I'm going to stick UI elements in various spots. And this tells me what's in what row and what's in what column. Okay? So, and yeah, it's green because it's kind of covering everything. I can go over here and look at its properties. Every widget that I put down in my UI, I'll make this a little bit wider so you can see everything. So every widget I put down in my UI has an ID. So we already set this for you. ID is just a string that you can use to refer to this widget if you have to encode. So you're going to wind up with some of your code. If you put new widgets in your UI, some of your code wants to talk about those widgets. So you need to have a way to refer to them. The way you refer to them is by giving them an ID. Okay, so we call this outer grid. It's nothing special, it's our name. And grids, as I said, are just basically a bunch of rows and columns that you can use to organize where are things. So we said our grid has 3 rows and 3 columns. So it divides up our UI into a 9-element grid. And that's kind of it, right? A grid doesn't really do much. It's just basically slicing up the space. So if I click on this button over here, I'll see what's inside the grid. Okay, so inside my outer grid are a few things, and I can click on them. So there's the main canvas. Okay, I clicked on it, and now you can see where is the main canvas. It's the green element, so top left. And the main canvas, its type, the widget type is GTK drawing area. This is where you're drawing your graphics. A GTK drawing area just says, I'm going to draw stuff on this, okay? I'm going to take care of it. And I can go over here and I can look at packing. Packing tells me right now, basically this tells me where is it. It basically says it says left attachment 0, top attachment 0. That basically means row 0, column 0. And in computer graphics, 0, 0 is in the top left. Okay, that's the coordinate system. And you can see that, right? That's the spot that's highlighted in green. It also says its width is 1 and its height is 1. That's in like these grid units. Okay, so it takes up 1 grid unit, it's top left one. And that's not the only thing. If I click on the status bar, it basically, if I go back here to general, tells me the ID is status bar. If I look in the widget view, I can see this is a different kind of widget. It's called a GTK status bar. And if I look in packing here, this tells me it's still in column 0, but it's actually in row 1. And it's 2 units wide. Okay, so that kind of makes sense. If you look in the UI, you'll see that it actually is below the canvas, and it's actually also below a bunch of buttons. Okay, it's taking two grid locations. And then the other thing is this inner grid. Okay, so inner grid, if I click on it, you see all the button areas highlighted. And if I look at it, it says it's got 7 rows and 3 columns, right? That's all a grid is, right? It's a set of rows and columns. So this is like a 7 high, 3 wide grid that we can use to organize our buttons. And if I click on this little arrow, I can see what's inside of it. There are a bunch of GTK buttons. GTK buttons are things you can click on and a function will be called. Okay, so those are the buttons that EasyGL built for you. If you use create button inside EasyGL, that's what it makes. Just makes another button in this region. And if I go and look in their packing and so on, I can see, well, where are they? And you can see that this arrow button, okay, right button is highlighted in green, and you can see it's 1 unit wide, and it's in row 1, column 2. But if I click on one of these buttons, you'll see that, well, they're in row 5 for this one, so it's lower down. It's also 3 units wide, right? The width is 3, which is why it looks wider than the other one. Does this make sense? So I just use this grid to like organize where are things compared to each other. They don't all have to be the same size even. Some of them can cover multiple grid locations. Everybody with me so far? Okay, so this view doesn't quite look like my UI. Like the buttons look really wide, right? And my drawing area looks really small. If I click on this button, this is a preview button. So it shows me what the UI would really look like. And you see the UI looks similar to what I had there, but I actually have an empty row and an empty column right now in my outer grid. So it doesn't render those, there's just nothing there, it doesn't do anything. And my buttons are kind of small compared to my drawing area because GTK actually figures out how big should things be. My button names are relatively short, so it doesn't have to make the buttons very big. So I actually get more drawing area, less button area, and I kind of like that. This doesn't do anything. If I click on these buttons, they don't do anything because this is just a view of the widgets. They're not hooked up to anything, okay? Everybody make sense? Okay, so let's go in and do something. Let's say that I want to go, okay, let's shrink this down a little bit. Let's do this. Okay, so I'm going to, okay, let's say I don't like my buttons on the right. Confuses me. What I can do is I can just click on the drawing area, the canvas, and I'll just put it here, okay? And then I can click on my inner grid, which is all these buttons together, and I can move them over there. Okay, and then my drawing area is kind of in a weird spot, so I'll move it back to the right. I can't put 2 things on top of each other, so that's why I had to kind of get the canvas out of the way first, so that I could actually move the buttons over, and then I'll move the canvas back. I could have gone in and just edited all the packing, like that's what's happened now. So if you remember my main canvas used to have a left attachment of 0. It was column 0. Now it's got a left attachment of 1. It's column 1. So I could have just edited those numbers, but it was easier to drag it around. And if I preview this now, my button is on the left, okay? So it's not very hard to move stuff around. Let's say something else I want to do here. So I'm going to click on main window. Oh, I guess I haven't done this yet. Maybe one other thing I'll show you is I haven't clicked on common and I haven't clicked on signals. Okay, so I'm not going to use those. These are basically, additional things I can use to customize my widgets. I'm not going to use those right now. You can experiment with them if you want. Signals, I do this in code. So signals are when something happens to this widget. Okay, so let's take this. I don't know if I can give you a really good one here. Let me see if I can find a better one. Okay, so GTK button has a callback called clicked. Okay, and that's when the person clicks the button. So I could actually right here type in the name of a function that should be called when it's clicked. I don't do that. I actually do it in code. So so basically everything you can do in this UI builder, you can actually also do in code. I like to use Glade to actually work out the layout of the UI, but when it comes to hooking up functions and so on, let's just go do that directly in code. But if you want to, you can do some of that hooking up here in the UI as well. that's basically what the signals in common are for, but I'm not going to do any of that. So you're kind of on your own if you want to do it here. I'll show you how to do that in code. One last thing though. Okay, so let's go back to the main window. So I clicked on the main window, I click on general, which are its basic properties, and let me preview this again. Okay, so see how well you've read the rubric. Is there anything in this UI that, well, basically, does anything that looks silly? Is there anything that's going to look bad when it's actually listed on the rubric that I should change right now? There is something on here that's right on the rubric to see. Do you read our rubrics? Do you go to our tutorials? Okay. You can even figure it out by yourself, so you don't have to do that. But what looks for your mapper? Okay, so this is fine for the tutorial, but for your mapper, is this the UI you want to hand in? What do you see? Right, that's exactly right. And you'll notice on the rubric it says, you know, name of application, EasyGL application example, or some kind of reasonable name, right? So we're checking, do you actually change this name? Okay, to change this name is really easy. I'll stop this preview now. I just type a new name in here for title, and it'll get stored in the main UI file. So I'm going to call this awesome mapper with like 2 exclamation points because I'm very pleased with myself. Okay, and now if I do that and I preview it, I mean, that's what you see. Okay, so you see awesome mapper. Okay, so I'm going to save this. So the save button's up here in the top right. So to save the current project. Now I'm going to shrink this down. And let's see, I'll run glade in the background. Okay, so I'm going to compile and run my program. I don't even actually have to recompile it because it just changed data. I didn't change source code, but I'm paranoid. I like to recompile all the time. Okay, so, and when I run it, you can see, let me make this bigger. Okay, the menu is on the left side and the name has been changed. So I've already achieved something. And everything else works the same way it used to work. Okay, so I'll just exit this. Whoops, let's go back to. Oops, I don't want that either. Okay, can everybody see that again? So maybe I shouldn't have actually gone back here. Okay, so I'm gonna do another demo where I wanna do 2 things. So I wanna add a widget for entering text. Right now, we've got buttons in our UI, but we don't have any way for a person to type text. And that's kind of annoying, right? They might need to type some stuff. So I'm gonna make a widget so they can enter text. The way I'm going to do this is I'll make a widget so they can enter text, but I already have a Pinkify button that I added to my UI at the end of last tutorial. And I'm going to use my Pinkify button to get the text. Okay, so enter the text, and when you hit Pinkify, I'm going to grab it. So we're going to do that for now, because it's a little bit fewer steps to do that one. Okay, so I'm going to put my UI back where it was, because I kind of prefer the, I prefer the graphics on the left, so I'm going to move this over. Okay, so I'm just clicking on things, moving them around. Okay, so that's back where it was before. And now what I want to do is basically here, in this group of buttons, I'm going to add a new widget called for entering text. Okay, so how do I do that? So the first thing, I'm going to put it in my inner grid. So I want to put it in with these other buttons, like on the right-hand side of my UI. Right now I've got space for 7 rows worth of buttons, and I'm actually using all of them. So the first thing I'm gonna do is gonna make space. So I'm just gonna make that 8. And you can see now there's an empty row down here. And this grid is actually 3 units wide, so it's actually an empty row with 3 columns in it. So I've got some space to put stuff. So I need to figure out, well, what's the widget I want? And there are a few ways to do that. GTK has a lot of documentation, so I can go search the documentation. You can do that on the web. The quick start guide shows that. There's also a documentation here. Okay, so in the GTK, right, I just clicked on that, and this might be a little bit less organized than the documentation on the web. So let's see, I'm going to show you the documentation on the web. So this is our quick start guide. Let me show you the start of it. Okay, this is on Quarkus, the GTK and Glade quick start guide. If you want to do anything in Glade and GTK, you should read it. But here near the end is a link to the GTK documentation. So I'm going to click on that. And if I click on classes, it basically has an alphabetical list of all the widgets that I can use. And I might have to go look through this a bit, seeing, well, what widget do I want? I already know what widget I want, so I'm just going to skip down to it. It's GTK entry. Okay, and it tells me the GTK entry, let me make this a bit bigger for you. Okay, let's see. Okay, so the GTK entry widget is a single line text entry widget. Okay, and I can learn lots more about it. I click on it. It basically gives me a description of it and all sorts of information that I don't want to go through all of it right now. Okay, but there's like extensive documentation. If you use GTK widgets, you're going to have to read what they do. Okay. So let's go back here. I'm going to close this documentation link. This is the one inside Glade. But I figured out that I want GTK entry. Across the top here, there are actually 5 little buttons. These are for adding new widgets. Okay, so GTK entry is not about visualizing things. It's about controlling my UI, like entering data. So I know it's under control, or I can guess it's under control. And under control, I will have a GTK entry. Okay, so that's like the second item. So I'm gonna click on the GTK entry. And now basically I can go click and put it somewhere. So I just click there, and I've got a GTK entry. It's a text box. I'm gonna wanna work with this widget in code. I wanna be able to get this text. So in order to do that, I need to give it an ID. I'm gonna call it text entry. I need to remember what I call it here, okay? Because if I'm gonna ask for it in code, I need to get the name right. So I'm being careful that I capitalize this correctly, or the tutorial goes south as soon as I do the demo. And then there's a whole bunch of like options here, but I don't need any of those. I could preview this. Let's just preview this quickly, and you can see what it looks like. Okay, so I've got like an entry field in the middle of my menu area or button area. I feel like I'm kind of wasting space. So I've got space here on the right-hand side with nothing in it. So I'm gonna go to packing, and I'm just gonna say it's 2 units wide. Okay, so by saying it's 2 units wide, I get a little more of my real estate over here. And the reason I didn't make it 3 units wide is actually, well, let's preview this again. So I preview it again. Okay, I got a little more real estate for typing stuff. Do you think how are people gonna know what to type in there? What do you think? It's gonna be kind of hard. Like I just have like a place where you can type, and I have no indication of what you might type there. So I wanna put an indication of what you might type there. So let's see. So under display, there are a bunch of widgets that are for displaying information. And one of the very basic ones is called GTK label. So I'm going to click on where I want it to go. So I selected it, I left click, and I get a GTK label. Okay, I'm going to give it a name. Let's call it the text label. And it's packing, it's 1 unit wide, which is fine. And here, this label is like, what do I want to show up? Okay, so let's call this, I'm gonna connect this somewhat to my Pinkify button. Like when you click the Pinkify button, I'm gonna grab the text and display it. So I'm gonna call this pink text. May still be a little baffling to the end user, but I put a label on it. Okay, so let's preview my UI again. Okay, and now you can see what it looks like, right? So I have this label right beside it, so people have some idea of what they might type here. Everybody with me so far? Okay, so I'm going to save this so they can go ahead and run it. Okay, so I'm going to go. Okay, so I'm going to show you the code next. And can you guys read this, or do I need to make this bigger? Who can read the code, or is it too small? It's okay? You guys have good eyes. Okay, so I'm going to call this function draw map Pinkify with text. I have like lots of different draw maps. Okay, what does it do? It basically does the same stuff that you've seen a bunch of times, except it has a slightly different initial setup callback function. Okay, so here's my initial. Remember when we call application run, the first function pointer we give it, first callback, is the one that will be called as soon as the window is created. When I need to hook things up to GTK widgets, that's where I want to do it. Okay, the reason I do it there, well, why do you think I guess I'll show you the code first. So I basically said, this is my initial setup callback. And then if I go up here, I'll show you what's in that. Let's see. Actually, the one that I just said is this one up here. Yeah, draw map Pinkify with text. And it is initial setup text entry. Okay, so this is it. So this is my initial setup callback, right? And if you may not have seen this because I went through it pretty quickly, but basically in this version of draw map, that is the function name that we're passing in as the initial setup callback. So as soon as the window's created, this function will be called. What does this function do? It uses the EasyGL create a button function. Okay, so it's this nice convenience function that creates a GTK toggle, like a button that you can click on and it just does whatever you want. And it says put it in row 6, and it says its callback is this function, toggle pink with text. All right, so this is actually using EasyGL code to make a new button, and I can do that. I can kind of mix and match. I can make a bunch of stuff in Glade, but I can make additional UI elements in code. So that's what I've done here. And basically, I've connected this button called Pinkify to this callback function, toggle pink with text, that'll be called whenever you click on it. Okay, what does that do? It does the same thing we had at the end of tutorial 6. We basically changed that state variable Pinkify, that's our background, is it pink or not? But now we do something else. I basically am also going to get the text that's in that text entry field. And the way I do that is the EasyGL application, okay, so that's this very important EasyGL object, has a method called getObject, and you give it the ID of some widget, like the name of a widget. Okay, so remember I used the name text entry? I have to use that same name here, and I basically get a pointer to it. And this code you just have to kind of look at as an example. The type is GObject. GObject is like a GTK pointer. Okay, so the pointer to a GTK object. I'm going to show you this in a second in the documentation, but or maybe I'll show it to you right now. Okay, so let me go back to the GTK documentation. GTK basically uses inheritance. You remember inheritance from 244? You can do inheritance in any language. So GTK does its own version of inheritance. Okay, so what does that mean? If I go down here, this shows the inheritance hierarchy. Everything in GTK is a GObject. That's like the most basic class. And a GTK entry, which is the thing I just made in Glade, inherits from GObject, and then in something called initially unowned, and then it inherits from widget. So widget is more specific than object, and a GTK entry is more specific still. Okay, so there's this inheritance hierarchy, and I have a GTK entry, but it also inherits from these other things. So why is that relevant? Well, this get object just gives me a pointer to a general GTK object. Okay, it's like give it a name, it gives me a pointer. I want to call some functions that only work for GTK entries. They don't work for all GTK objects. Before I can do that, I basically need to convert the pointer or cast the pointer from a GTK object to a GTK entry. And that's what I've done in this line. I've said I want a pointer to a GTK entry, like so a more specific pointer. And the way I safely do that is using this casting operator. This will convert the pointer if it's legal. If it's not legal, like it actually checks and says this is not actually a GTK entry pointer, it will give you a warning. Okay, so it's better than a raw cast. And now I can call a function that I'll show you in a second. I can look up in the documentation. There's a function called getText. So given this pointer, I can say, give me the text, which it returns to me as what it calls a GChar, GTK char pointer. So it's a C-style string. It's like a pointer to a bunch of characters. And what do I do with that? Well, I basically pass that character string to the update message method of EasyGL. So that's going to put that string in the status bar. Right? If you remember from tutorial 6, I said you can put things in that status bar. That's what I did. I want it to show up right away. Well, I want the background change that I did to show up right away. So I call refresh drawing as well. Okay, so the new code that was not there in tutorial 6 is this. And it's basically code to get me a pointer to the text entry, like this GTK entry, convert the pointer to a more specific type, and then I want to call one method on it, right? Get me the text. Does that make sense? Okay, and I'll come to your question in 1 second, but this looks mysterious, and there is some, you do have to do some reading of documentation. But basically, if I keep reading down in this GTK entry, you'll see it has documentation on all the functions, and they all start with GTK entry. And the one that I called is called GTK entry get buffer. Okay, I think. Let me actually go and look, make sure that's the exact one I called, because there are a lot of methods here. I say it's GTK entry get text. So let me keep going down. Maybe I'll go down here. So. Okay, so this is the GTK entry get text function. Okay, and it tells me what it does. And it basically just gets me the text that this thing has in it. Right, so there is the function. And if I click on it, I get more information. Okay, so GTK is a big library, right? So if you're going to use it, you're going to do a bunch of reading of what's the right widget, and then you're going to read in that widget what are some of the methods to see what do I need in order to do what I want. So I just wanted to get the text. That's all I needed. Yeah. So you had a question?
Yeah, I have 2 questions.
Sure.
First, is there a function to make the entry through this, or do I have to usually?
No, you can do it. There is like create, there are basically create functions and so on. So if you didn't want to use glade at all, you can basically create this text entry with appropriate code in your initial setup callback.
And second, why do we cast it? Why couldn't we just do GTK entry and make the pointer right away? Why didn't we make an object for object pointer and then cast it?
The reason to cast it like this is these GTK conversion functions are like safe functions. I mean, I could have written this all in one line. So I could have done this. If this is what you're asking, are you saying, why didn't I just do this?
Why couldn't it just be type
I could have done this, okay? So maybe I'll just, like if you just went, why do I need 2 lines, just do that? Yeah, I could have done that, okay? But I wanted to show it step by step. The reason that you have to do this casting is it's basically, GTK doesn't want to do like implicit conversions. It wants you to say, okay, I believe that this pointer to a generic object is in fact a GTK entry. I want you to convert it for me. And this GTK entry function will actually check. Inside of the object that this pointer points at, it actually has a hidden type field. So it's actually going to check, are you really a GTK entry? Or do you inherit from GTK entry? Like, is this valid? And if it's valid, it'll make the conversion. If it's not valid, it'll give you a warning. Does that make sense? So it's better than doing, if you know that C++ has many ways to cast, it's better to cast it this way because GTK is checking for you, is this actually valid? Whereas there are some other ways in C++ where you just force it, whether it's correct or not. This is better. Does that make sense? Okay, so let me run this now. So let me build this and run it, and let's see what happens. Okay, so let me make this bigger. So here's our map with all the intersections that hopefully you know and love. In Glade, I had all of these buttons, except they didn't have Pinkify, right? So remember, I never entered that in Pinkify. So that's part of your question about, do you have to create everything in Glade? No. In fact, I used EasyGL's create button function to just make another button. And I said I wanted it in row 6, so it just basically inserted it in the middle of the other buttons. And that's fine. So you can mix and match. Remember, my Pinkify button just turns things pink. I can still zoom in and out, etc. All that stuff's still working. But I can also now type text like test text. And if I hit Pinkify, I actually, remember I put my get the text and put it in the status bar function. I put that in my Pinkify callback. So what that means is I have to click Pinkify. And when I do that, if you look over here in the lower left corner, you'll see it says test text. Is I grabbed the text and I basically said, put it in the status bar. And the status bar, it'll stay there as I do things. Okay, so it'll just stay there if I basically put some more text in here. So I'm changing the text. Notice the status bar is not changing, okay? Because right now I'm just messing around with the entry. And now I'll change it to entry text. And when I click Pinkify, it copies it to the status bar again, okay? Because that's the way I set it up. So probably if I did this for real, I wouldn't make that button called Pinkify. I'd probably make it called enter, or enter text or something, or return. So that it was like not so confusing, or go, but that's a way that I could do this. Yeah. Is it to make it continuous?
Yes, as you type it, it shows.
Yeah, so good question. So you can, okay? So let me go back to GTK entry. Okay, so I'm back at the documentation on the web for GTK entry. And what I'm going to look at is, okay, so this is all the methods. I don't actually want the methods right now. Let me go back a couple times. Okay, so I'm going to go classes. I go to GTK entry again. All right. Okay, so the format of this documentation is always the same. It's a description of what is this widget. Yeah, I'll make it a little bigger, so hopefully you can, whoops, maybe not that big. Okay, it's a description of it. It has basically styling, which you're probably not going to use. I made a post on how to do this, but that's if you like really want to customize the look and feel, you can use CSS styling, okay? It has this hierarchy, so you can see, basically I can call any function of GTK entry, but I can also call, whoops, I don't want to ask Copilot. I can also call functions of its ancestor classes. So that's why it shows me this hierarchy. And then it shows, and this is just saying what are the ancestors. It has instance methods. So these are all the functions I could call, okay? And if I keep going down here, let's go on the left side. It also has something called signals. Oops, maybe I shouldn't click on, I guess I can't click on that. I guess I have to just keep going. All right, so lots and lots of functions that I can call on this. And if I want, I can go click on, what did I inherit from its parents? So there's even more functions. Okay, let me keep going down here. Okay, so now I'm into the section called signals. And signals are events. Okay, something happens, I can attach a callback to that. I can register a callback in my initial setup saying, when this happens, call this function. Does that make sense? I'm going to show you how to do that in the next demo. So let's say you want, okay, so the most basic signal for GTK entry is this one, activate. So activate is called when the user hits the enter key. So that means that I don't really care what this person does until they hit enter. That's pretty common. Okay, so I could just hook a callback to that. I haven't done that yet, but I'm going to do that in the next demo. Let's say I wanted every single key press. If I look through these signals, you'll find that there is actually nothing that there's no signal for key press. But if I go back to GTK widget, one of its parents, let's see, I think it's in here. Let's see, or maybe it's in the editable. Basically, there's a key press signal. I just can't remember. I have to like look through the documentation. There's another signal called key press. That gets called every time the key is hit. So if you decided I want to wait till enter, you would hook up to that callback.
How would I search for it? So I was going to GTK.
Let's see. Let's see if I can find it. I'm going to go back again. You do have to do a bit of looking around, okay? And it's actually much harder to do when you have lots of people watching you. So I'm better at searching this like on my own desktop, trust me, because I'm probably making it look a little harder than it is. And let's see, signals inherited from GTK widget. Oh no, this is it. It is in GTK widget. I think I just clicked on the wrong thing. So I'm pretty sure it's in here. Okay, there it is. Okay, so key press event. So, and this is basically something on widget, which is one of its ancestors. So I could say GTK widget of this GTK entry to get a pointer to a GTK widget, and then I could pass that into, like I could basically use this. Does that make sense?
And we use it the same way that we use the pick file. You know how you type it in, and then when you click the pick file button, then it updates. So how would you like?
Well, so I'm going to show you how to do it for activate in a minute. I didn't show it for key press. Basically, there's like many ways to do this. That's why there's so many signals. But basically, if you wanted to take some action every time a person clicked a character, then what you would do is, I'm going to show you how to register callbacks in a minute. You would register a callback on the key press event. That means you're basically saying, call this function that I've written every time a key is hit in this widget, and then it's up to you to decide what to do. Okay? Nobody can know what you want to do. Let's see. So,
I have a question about
yeah.
So when you press SX into the search bar, did it redefine all the intersections because all the intersections are by default SX?
No, so basically, I'm just hooking stuff up. Like I'm not saying my overall UI has any logical purpose. So I made a pinkify button, which still changes the background to pink. Okay, so it still does what it used to do. Okay, so it goes pink, not pink. And I just used it also to demonstrate that I can grab the text from this text entry. So I have no idea why, right? So if I do that and I hit pinkify, it copies that to the status bar. Like you're asking why would the pinkify button do that? It does it because I told it to. I'm not saying there's any like grand logic to my user interface design. It's a little bit baffling. So does that make sense? And the flipping the background is that's just what I wrote. I still want my pinkify button to do that. Okay? So that's it for that demo. Let me go and do one more UI demo and then we'll move on. Okay, so what I'm going to do is last one. It's my last demo with Glade, so last chance to ask questions on it. This basically is just the code. Okay, so this is basically showing you the code that I wrote in the pinkify button callback to get the text. So you have a record of it. But we already talked about that. Okay, so last demo I'm going to do, I'm going to show you two different things. I'm going to show you a GTK overlay So far, we've been using grids to organize our layout. And grids organize things like spatially. This is to the left of that, this is below that, okay? You can also use overlays. Overlays let you stack UI elements. And if you look at Google Maps, you'll see it doesn't just have all the buttons in like a certain menu area, it kind of sticks buttons all over the place and like text entry fields all over the place. Overlays let you do that. So I'm first gonna show you how do you create an overlay. And then the second thing is I'm going to change my text entry a little bit so that I actually directly register some callbacks so that I can get the text when the person hits enter. Okay, so two things. And let's go do that. Okay, so the first thing I need to do is I'm going to keep editing my UI. And let's see. So what I want to do is basically I'd like to be able to put buttons on top of my drawing area because I think that'll look cool. I think it'll look a little more elegant than just having buttons off on the side. So some of my TAs, when they I made this UI layout and they're like kind of, yeah, that's a pretty boring UI layout, right? You just have buttons and a bar on the right and then you have text on the left. So I want to get some buttons on top of my, or some widgets on top of my graphics. Okay, so how do I do that? So first, I still want my graphics in the top left. So I'm actually going to move my drawing area out of the way again, my canvas. And this is a different kind of, let's see, should be in here, yeah. Okay, so a GTK overlay is a different kind of container. A grid is a container, it's just for organizing things. An overlay is another kind of container. So I'm going to click on this GTK overlay, okay, and I'm going to put it here. Okay, so it's in part of my outer grid. Now an overlay doesn't do anything. It's like a grid, but it's like a vertical container. I can stack stuff. So I'm going to take my main canvas, and putting things on an overlay in Glade is a little confusing, but basically the easiest way to do it is you can just cut things. So I can cut this, and then I'm going to paste it into the overlay. All right, so now my main canvas is inside my overlay. If I click on packing, it actually doesn't have like a row and a column, it has an index. This index is like, where are you in the layers? So this is -1, it's like the lowest layer. The first thing drawn is going to be my canvas, which is my graphics. And now I want to put something on top of it. So I'm going to put on top of it a different kind of control. So I'm going to put on a GTK, where is it? I'm going to put on a GTK switch, okay? So I've got a GTK switch, and to put it on the overlay, I just left-clicked on the overlay, well, I right-clicked on the overlay, sorry, and I'm gonna say, actually, could you two, hello? So just kind of keep it down, please. So I'm gonna say I wanna add the widget here, okay? So I right-clicked on it, and I say add widget here. You would think that if you just said, let's do this again. Let's say I wanted a lock button. If I just take it and I try to like paste it there, it doesn't work, okay? So you can't just click on it. You have to go to the overlay, right click, and say add widget here. That confused me for a while, so remember that. And if I go look on the GTK switch, and I look at its packing, its index is 0. Okay, so the packing of the canvas is -1. The packing of the GTK switch is 0. So it's on top. Let's preview that to see what it looks like. So click the preview button, and basically a GTK switch is just a little toggle you can turn on and off. And GTK will handle, this turning green and moving around. That's part of like the widget. You don't have to do that. Okay, so doesn't look all that exciting yet. So I'm going to close this down. Oh, and the last thing I need to do is I need to make sure I give my switch a name. So I haven't given it an ID yet, but I actually want to be able to talk to this in code. So I called this Think Pink Switch. And let me make sure I did that. All right, let me go down here and see what I called it. Yeah, I called it pink switch. Okay. Okay, so now I'm gonna save this. Okay. And I've already pre-written the code that I need to talk to this. So okay, so you know all this code. This is like the setup code to get the application going. You've seen this many times. The only thing I've changed here is I've changed what the name of my initial setup callback is. Okay, and let's go up and look at that initial setup callback. So this is what it is. And remember, ece2 always calls this initial setup callback once the window's created. And what I'm doing in here is I'm basically getting pointers. First, I get a pointer to this pink switch, okay, a G object pointer. And then I pass it into this routine called gsignal connect. Gsignal connect registers a callback. What that means is GTK has a table of what do I do when various things happen, okay? So it's basically saying for pink switch, right, this UI element, when a signal called state set or an event called state set happens, that means the person switched it from one side to the other. I want you to call a routine that I have to write, and the routine that I wrote is called pinkify switch, and you have to wrap it in this, again, casting operator of G callback, so just memorize that. And then the last thing here is I can pass a pointer to some data that I would like my callback to have access to. Turns out most callback functions that you're going to write, you can't do much without the ece2 application pointer, so I'm going to pass the ece2 application pointer in. So this could be anything. I could even make it null if I don't need a pointer, but this is basically GTK's way of saying you might need some data in the callback. If you give me a pointer to some data, I will send it to your callback when I call it. Does everybody basically understand that? So this is like connection. This is like wiring things together. So that's one callback I want. The other one I want is this text entry. Remember, that's the name. Text entry is the name that I gave to my GTK entry field. I basically say get that object, and I'm going to call that pointer that I just got text entry as well. And I'm going to do another connection of a callback. I'm going to say for that widget, the text entry widget, when the activate signal happens, and remember I just showed you in the documentation, what is the activate signal? It's when enter is hit. So that's the only way I know what the signal is called. You have to go look it up, okay? And that's how I looked up what is the signal that happens when the state is switched on a GTK switch. Okay, and I basically say what function it should call when this happens. So I've written a function called text entry enter, and I'd like that function also to have access to the application pointer, so I'm going to pass it too. Because I get to pass exactly one pointer. Does this make sense? So gsignal connect always takes 4 arguments, and they're always these same things. And I'll show you that again in the slide. But basically, I've hooked up 2 callbacks, one to each of these 2 widgets. And then I have to write the actual callbacks, okay? So, well, I can delete this. I don't need that. Okay, so one of the callbacks is what do I call when you hit enter in the text entry? And in that callback, I basically have the same code I had before. I say, I want you to get the text out of the text entry widget. Now the text entry widget, a pointer to it is actually passed into my callback. So I don't even have to use that get object. It was actually passed right into me. So I just directly call your get text, and then I say update the message that ece2 has, that status bar. The switch, that toggle that I just put in the middle of my graphics, I basically have hooked that up to this callback, and this callback, basically what it's going to do is it's going to switch the pinkify variable. Okay, so this callback gets called with an extra thing, right? It gets called with one extra parameter, which is a Boolean variable that is the switch on or off. Because GTK knows whether the switch is on or off, it actually passes that into me. So I'm going to use that variable that was passed in. I'm going to basically update the pinkify state variable that says if my background is pink or not based on that. And then I want the background to flash right away if you've changed it. So I basically say refresh the drawing. So this is almost the same code I had before. It's just now it's hooked up to this GTK switch. And you have to read the documentation carefully. So this function also has a return value. Okay, so this callback's a little different, and that's in the GTK documentation. The callback for the state switching in a GTK switch returns a Boolean value. And when I read that documentation, it said, if I still want GTK to actually kind of update the switch color, and move the switch for me, I should return false. If I return true, it means I will take care of it. It's like, I don't want to take care of that, so I return false. Does that make sense? Okay, so that's it for all of this. Let me build it and run it. Okay, so here's my new UI layout. Notice there's no pinkify button. So in my initial setup, I didn't actually make a button anymore for pinkify because I don't need it. Let me zoom in and stuff so you can see this. If I move this around, you can see the switch probably a bit better. Whoops. So I just clicked on it. So basically clicking on the switch now allows me to change this, like turn pink on or off. Does it make sense? And then if up here, I can type some text in. So test text, nothing's showing up in my status bar, but if I hit enter, now it shows up in my status bar. And that's probably a more intuitive thing. So I hooked up a callback to the activate button. Okay, does that make sense to everybody? Okay, so let me go back here. Okay, this is basically the code that I showed you. So my initial setup basically gets pointers to these two UI elements, hooks up a callback to each one. So G-Signal Connect always works the same way. It needs to get the ID of the object. Well, actually, I got to change this. The ID in glade. Here, let me change this actually. This should be the ID in glade. So let me move that over there. Okay, so that's the name I gave it in glade. And let's see if I can move this over nicely. Okay, so you have this ID that you gave it in glade. You use getObject to get a pointer to that. And then you're going to pass that pointer to the widget into G-Signal Connect. You're also going to pass in, well, what signal? Like, when do I want this callback called? You have to actually say, what is the name of the function that should be called? And you have to write that. And then the last thing is a pointer to anything. Okay, so, and most commonly you will pass in the EasyGL application pointer because you probably want to call some of its methods. But if you wanted some extra data, you could make a structure that has a whole bunch of data in it, and then pass a pointer to that. So one pointer is actually enough to get at any amount of data if you just make a structure and pack it all together and pass a pointer to it. And I do the same thing for my text entry, my GTK entry. I just do it on the activate or enter button. Okay, so that was part of what I have to do. I have to hook up the callbacks in initial setup, and then I have to actually write the callbacks. And this is the code for the callbacks, which I already went through with you, right? It's not very complicated code. Just does whatever I should do when that event occurs. okay? And the callbacks get passed as their first element, but their first input parameter is a pointer to the widget, so that's helpful. You can now call the methods of that widget. They also get passed that pointer that you set up in the callback. So in my callbacks, when I set both those up, I said, I want the application pointer, the EasyGL application pointer passed. So in my callback, that's what I get passed. So that's the way I've written my callback. And that's helpful because here I'm using things like application update message. But I hadn't passed in that application pointer, how am I going to call that? Okay? Not all callbacks have the same function signature. Okay, so the function signature for a GTK switch, when you click on the switch, is different. You still get a pointer to the widget. You still get a pointer to the data that you said, that you hooked up in the callback set, or the gsignal connect. But in this case, I actually get another thing in the middle. I get this a Boolean variable called switch state, because the creators of GTK went, well, you probably want to know if the switch is on or off. That's the whole point of this UI, so they pass it to you. And this particular function also doesn't return void, it returns a Boolean. And that Boolean says, do you want GTK to do the usual update of the switch state, like visual update? So, so what this means is you have to read the GTK documentation carefully, right? When you set up a callback, you got to get the exact right parameters. They're not always the same. Yeah. Why is it? Oh, this one? I commented that out to avoid a warning. So you notice that I don't actually need to do anything with that pointer to the widget, which means by default, like we turn warning level, turn on all sorts of warnings, including will warn you if you have an unused variable in the function. So if I didn't put this, if I comment this out, it tells the compiler, while there is an input parameter of type GTK switch pointer, I'm actually not going to name it because I commented out the name, which tells the compiler, like, on purpose, I'm not using this, okay? Now, so it's actually a really good question. If I didn't do that, I'll get a warning. Warnings are bad practice. You could also say, well, if you're not using it, why don't you just delete it? Would it be okay if I just deleted it? No, it'd be terrible, okay? Because GTK doesn't know I deleted it. It's going to push that parameter on the stack. So one of two things is going to happen. The compiler is going to complain and it doesn't match, or even worse, the compiler doesn't catch it and then my program crashes. So you have to match the signature of the function, callback function, exactly, okay? You don't have to use all the data, but you have to hook it up. You have to put a placeholder for everything. Okay, so that is it on GTK. Yeah. How do you offset it? Yeah, so inside packing, there's all these detailed things that you can move it around and stuff. So, but this is already a long enough tutorial. And it's highly stressful actually working with tools. Like programming in front of a lot of people actually makes me like, I think I lose 40 IQ points at least, right? And I think I only started at 90, so it's really bad. So, but yeah, there are settings to move it around. So if you do an overlay, you're probably gonna wind up monkeying around a bunch with like packing settings and so on to put it in the right spot. Does that make sense? I think they're primarily not in packing. They're kind of like, there's all these positioning variables that you can set in Glade as well. Okay, so if there are no more questions, let's take a break until, let's see, I kind of went a bit over time there. Let's just take a short break to like maybe 4:21. Okay, so take a 5-minute break and we'll talk about profile. Okay, so we're gonna get going again. So now this is a totally different topic. Okay, so we're done with like kind of making things look pretty. Now we're gonna talk about performance. Okay, so computer engineers want to make things go fast, and in milestone 2, your challenge is to make your redraw function fast. pretty much nothing else matters. Well, you don't want your load map to be ridiculously slow, but pretty much none of your other functions are going to matter for speed except your redraw function. That's going to define how responsive your program feels. So what do you, and probably your redraw function is not going to be as fast as you want. So what can you do? So what you know, yeah. That's a good idea. I would just switch off the part. So you remember things from the last tutorial. That's great. So yeah, pre-computing is a very good idea. You're going to use that technique, but let's say it's still not as fast as you want. You can start trying to improve the codes, but it's a bad idea to improve things without being able to measure what's going on. So what you know how to do right now is big O analysis, and it's a very useful thing to know. So you try not to use inappropriate data structures or algorithms. You can do some guessing based on what you learned at ece294. Like I think I'm copying a big object here. Maybe that's slow. You can guess based on I just have a feeling. People do this all the time, but it's not a great way to optimize. You can also time things. So you can try stuff and then do controlled experiments. Use the stopwatch on your phone to see did it get faster or slower. And if it takes long enough, that might be usable, but for things that are run pretty fast, this isn't going to be very accurate. Okay, so you're going to use those things in your toolbox. We want to give you some more tools. This is a quote from Lord Kelvin, right? Creator of the Kelvin temperature scale. If you cannot measure it, you cannot improve it. And it's very true. I mean, that's like a key part of engineering and agile development. How do you set up measurements so you can tell if things are getting better or not? Okay, so what can you do to measure? So 3 techniques we're going to go over in this tutorial. First one is manual measurements. So they're like using your stopwatch, but more accurate. So you write code to measure time. I'm going to show you the code that you can write. Benefits of this, it's the lowest overhead. So getting the time from the processor has a very, very accurate clock, and it does not take much effort for it to get the time. So it can measure small amounts of time quite accurately. So you can measure even individual loops, even things that are smaller than a function, which is hard to do with most other techniques. So that's good. But you have to write code. So if you want to measure a lot of different things, you wind up writing a lot of different code. So that's kind of a pain. What I'd suggest is at least your redraw function, you actually do write code that times it, and you just leave that code in there, right? Or at least you have the ability to turn it on and off, because you'll probably want to measure this over and over again. So write it once, leave it around. I'm going to show you another technique that is basically like random sampling using the debugger. So in the debugger, there's a pause button and a continue button. And so far, you've usually been using continue after breakpoints. But you can just hit the pause button at any point. So when you hit the pause button, have you guys studied in 243 interrupts yet? Okay, so you're interrupting the program, and you can actually look at its call stack. You can look at its variables. You can look at everything. So you're just randomly interrupting the program and seeing where is it. And if you do that 10 times, and it's always in the same spot, you have a pretty good idea. That's where I'm spending most of my time, right? So it's like a boss going to the factory and just randomly interrupting employees to see what are you working on to try to figure out what takes the most time. The last thing you could do is use a profiler. Who knows what a profiler is? Have you ever heard this term before? Okay, so a profiler basically does the same thing I just talked about of hitting pause and continue, but it does it automatically. So it interrupts your program many times a second, and it records what function it's in, and also how did it get there. Okay, so you're in this function, you got here by going through this path of functions, and then it can summarize the results for you. So it is literally like if you could hit pause and continue 1,000 times a second, because by default, that's how often it interrupts your program, and you could write all that data down really fast, right? And then make some graphs and so on. That's what a profiler is doing for you. Okay, the benefit of the profiler is, you didn't have to write any code, and it's gonna sample where do you spend your time? So that's great. You get kind of a lot of data. The downside of it is there is some overhead. Interrupting 1,000 times a second and recording a bunch of data does slow your program down, so it increases some overhead. And I'll talk about another couple trade-offs when we get there. Okay, so let's talk about first, maybe the most basic technique. We're going to measure performance manually, but we're going to do it better than using a stopwatch. We're going to make the program measure itself. So the way we do this is processors know the time very, very accurately. So we're going to get the timestamp before, the region we're trying to time. Okay. Then we're going to get the timestamp after, We're going to just subtract those 2 times and print it out. Okay, so the algorithm is pretty simple. So I'm going to time this act on button press routine that we wrote in tutorial 6, right? You click the mouse button in the graphics area. What do we do? How long does this take? So, and I want to time the whole routine. So I'd really like to get all of this. So I want to get the timestamp before this code executes. And this is the code you want. So C++ has a library called chrono for time. It uses a whole bunch of namespaces. So it's in the standard namespace, in the chrono namespace inside that, inside a high resolution clock object, and it's got a function called now. Okay, so it's a long name, take it off the slide, okay? But what that does, and it gives back a complicated type, right? Like the type of the object you get back is similarly got a long name. So we're just going to use auto. This is where like, I don't really care what the type of that is, just whatever it is, store that thing. We have our regular code here that figures out what intersection did you click on. Okay, now I want to get, what time is it now? So I just make the exact same call to chrono, but I just store it in a different variable. Okay, so I have a start variable, I have an end variable. I can subtract those. And so chrono basically allows me to subtract objects. These are some objects, but the subtraction operator is overloaded. I subtract them. And then again, this is a little bit of code that you just have to use or look up. Basically, this says take that difference between the objects and turn it into a time in seconds. And now just print it out, okay? And when I print it out that way. I've got this new object called delta time, and its count member is going to be the time in seconds. You can just take these 4 lines of code and use them, okay? Because they will always work. So this is going to time some code. Does this make sense? And you can put this in your program all over the place. So you can time lots of stuff. Now, if you time lots of stuff and you just print it out to the screen, it could get hard to read. Okay? Maybe you have hundreds or thousands of lines of timing, and it's just very confusing. So I've written in our reference solution this code. So we made a little function called profile CSV, or profile with comma separated values. And basically, I just pass in one of those chrono time objects, a starting time, and I pass in a string, which is the name of the function or the piece of code that I'm timing. And then this is the code I showed you before, right? Well, it's most of the code. Basically, I need the start time, and then these 3 lines of code are what I showed you before. They basically get the time now, they take the difference, turn it into seconds, and I print it out not to the screen, but I print it out to a file. Okay, so remember, I can use the output stream operator not just on cout. I can use it on any output stream. So what I've done, this is maybe I'm lazy. I used a global variable, but basically this line of code creates something called an output file stream. An output file stream is a stream, just like cout, but it maps to a file. I gave it the name of a file, okay? So it basically, when the program starts, this global variable is constructed, it will actually open that file. So I've got a file open, and now every time I call this function, I just print to that file. I print another line. And what the line I print to it is how much time has passed, and what is the function name that I'm timing. Okay, how do I use this little helper function? Well, basically, here's my act on button press. I basically just say, okay, get the start time using that 1 line of code, and then I call this profile CSV, and it'll get the time right now. So I pass it the start time, it gets the time right now, figures out how much time has passed, and I also pass it a string so I can tell what the heck does this go with. Does that make sense? So this code is just kind of a nicer way to do it. I've made it so that with 2 lines of code, these 2 lines, I can time anything I want, and I can write it to a file with a nice string beside it telling me what does this mean. And the way I write it to a file, if you look at this carefully, you'll see that I actually print the string, the name of the function, then a comma, then the time that's elapsed, and then a new line. Okay, so when I separate values in a file with commas, that format is called comma separated values, or CSV. Has everybody heard of that format? Ever used it? is a format that spreadsheet tools can read. So you can open it up in a text editor, but even better, you can open it up in a spreadsheet. And the spreadsheet will, basically, you can open up in Excel, and it'll actually show up as rows and columns. So it's way easier to read. So it's a really easy file format to write, but you can get it into a spreadsheet. Let's see. Okay, so I'm going to quickly demo that. Okay, so this is the reference solution for from the teaching team. And this is our main redraw function. So we called it draw. And I get the starting time up here. In some of this tutorial, it's going to be useful for me to slow this down. So I actually have a loop wrapped around our whole rendering code, so I can actually draw the screen multiple times in this. Right now, I'm not doing that. I just want to redraw the screen once, which is like what you would normally do. And you can see we've got some helper functions here. Okay, so we have a helper function that draws our features. We have a helper function that draws our street segments. We have a helper function to draw point of interest names, street names, and some other stuff like draw subway stations and so on. Okay, and you can see at the end of this function, I basically record how long this whole function takes, and I put a string of draw. If I go into some of these other functions, see if I can go into one of these, let's see, I probably should be careful how much code I show you because this is going on video. Yeah, so I guess I won't show you some of the other functions, or I'm going to have to be careful of what I show. Okay, so one of those helper functions, to show it to you, is draw all features, and it's not super exciting looking. It has some checks about how zoomed in am I to decide whether or not I should draw stuff, and then it basically goes through and it draws every single feature, okay? So let's just run this. Okay, let me compile this, I'm gonna run it. Okay, so my load map is running, my graphics are up. If you're timing things, it's actually a good idea to keep your window layout consistent. Graphics can slow down a bit with a bigger window, so I'm not going to make the window size different. And I'm just going to turn on my subways, and let's see, I'm drawing kind of everything it looks like. So I'm going to zoom in. Okay, so I'm zooming in. And as I zoomed in, you notice that it's eventually the building started showing up, and then now some names start showing up, and so on. Okay, so I zoomed in a bunch, I zoom out a few times, I'll zoom out to the whole thing, I'll hit proceed to end the program. Okay, so now what I want to do is I'm going to open up a spreadsheet tool. Oops, that's not what I wanted. Okay, so I want, okay, so under Office, there's LibreOffice Calc. This is basically Excel on Linux, right? So, and I want to go open up. Okay, so in here, the file that I wrote this to is called, let's see, where is it? This one. Okay, so it's a .csv file called funcperf.csv. I'm opening it up. And so it opens up nicely in a spreadsheet. Okay, so what can I tell? So I didn't show you all the things that we have timers around, but load map took 5 seconds. And then you can see my first redraw took 0.21 seconds. And I can also see the components because I put timers around the helper functions. I also put a timer around the whole draw routine. So most of my time was spent drawing the features, right? The parks, the rivers, etc. I didn't spend that much time spent drawing streets. Okay, but let's go down to some more redraws. So notice it actually got faster on the second redraw. My second redraw went from 0.2 seconds to 0.03. Your first redraw in EasyGL, there's some what's called lazy loading. There's some data structures we need. If we find they're not around, we create them. Okay, so your first redraw can be slower than others. Don't pay too much attention to it. This one's more reasonable. And it tells me my feature drawing is taking longer than the streets drawing, and nothing else really matters. Okay, I'm gonna go down here. So you can see I turned on subway stations, but basically nothing much is going on, right? Like I keep getting the same answer. Subways don't matter, features are slower than streets, and those are the only two things that are taking any real time. Okay, and my redraw speed here is about 0.03 seconds. As I zoom in, that one's now 0.02. I told you things tend to get a bit faster as you zoom in if you draw the same thing, because EasyGL can throw away the stuff that's off screen. So I got a little faster, 0.02. Now this one's a lot slower, 0.3 seconds. It's a lot slower because we zoomed in more. And if you were watching as I zoomed in, at a certain point, we turned on more level of detail. We started showing all sorts of buildings and small streets. So I can actually tell where my graphics slowed down because of that. But most of the time still in features, some of it in streets, like the street segments. Subways are not taking me very long, etc. Okay? And if I go through the whole file, I can see that's the overall trend. Does that make sense? Okay, so I can learn a lot from this. By doing this, first I can tell, I probably shouldn't worry about when I'm zoomed out. It's 10 times faster than when I'm zoomed in right now. And I spend most of my time drawing features. So if I'm going to optimize, that's what I should worry about. How many features do I draw? How do I draw them? Okay, so I'm going to close that. It's all clear? Okay, so grab that code. It's very useful. Let's bring up this. Okay, that was release build. Do you think I should use release build for what I was just doing, where I was timing things? What do you think? Yes, that's the right one. Okay, that's what I care about. So I'm now going to start the debugger. Now, usually we don't debug the release build just because it's harder to reason about, because as I told you, you can actually have, things can be reordered a bit and so on. But I'm not trying now to reason about the build. I just want to do what the second thing I told you. Actually, maybe I should go back and show you that second thing. Okay, so actually let me go back here before I do the second demo and tell you what it's about. Okay, so timers are good, but you have to actually write code. And if you don't have any idea where things are slow, you might wind up writing a bunch of code. So sometimes there are other things you want to do. So this is where that random sampling comes in. Okay, so let me hide these. So we're going to run the debugger. We're going to pause it. We're going to look at where we are, and we're going to do it over and over again until we get bored. If we keep showing up in the same routine, that tells us that's probably slow. There's another thing we get out of this. It doesn't just tell us we're in a certain routine. We can even look at the variables. So I showed you that I'm spending most of my time drawing the features. Maybe it's just a few really slow features, right? We have some polygons with a lot of points. If I find that I'm in draw features, but I'm also there for a certain particular feature all the time, it would actually tell me even more, right? That feature is slow to draw. Okay. Okay, now in this case, pausing and continuing the program is going to be a bit challenging because my redraw is too fast, right? When I zoomed in, my redraw was still 0.3 of a second. I can't click pause and continue much. So this is why I wrote a loop around the redraw function. I'm going to make it redraw 30 times so that 30 times 0.3 is like 9 seconds. That's long enough for me to click pause and continue a few times. And then if I need more data, I'll just do another redraw. I'll force another redraw by clicking on something in the GUI. So I can use any build I want, but release is going to give me the most accurate answers. One thing that release does is it does function inlining. So some of my short functions will actually be pasted into my longer functions, and I will not see them anymore. So we make another build for you called the profile build, which has all of the optimizations in the compiler turned on except function inlining. Your program will run slower, maybe 30% slower, but every function you wrote is now visible. So there's no perfect answer of should you, like, when you're doing this this profiling and the kind of profiling I'll show you next, should you use release or profile, they each have strengths and weaknesses. The release is the real picture, but the profile build makes sure that every function exists, so you get a bit more detailed information. But neither one is perfect. Does that make sense? Okay, so I'm going to quickly demo this. And let's see. So yeah, I'm going to do the release build. And I can run the debugger on the release build. We usually don't do that, but we can. So I just started the debugger. With any luck. Okay, so it's come up now. Oh, and actually I made a mistake. So what I need to do though, is this is going to be too fast. So I need to go find my draw function. I need to change my num redraws. Okay, because I am not that fast. I can't click fast enough. So I need to build it again. And I'm intentionally slowing my redraws down by a factor of 30. Okay. Okay, so if I hit pause now, I'd be in load map somewhere. So I don't want to hit pause yet. Okay, now I'm here. I'm going to zoom in a few times. I'm going to turn on subways. I'm going to zoom in a few times till I get to where most of my details are shown and things are slower, because that's what I'd actually like to profile. I'm not as worried about when I'm zoomed out and things are pretty fast. Okay, so I think now I might be in where it's slower. Or maybe I just need to zoom in more. Okay, so I'm going to make this a bit smaller so that I can have my UI and my code beside each other. Okay, so if I pause this, so I just hit paused and I can look at my call stack. So let's get rid of this. And let's see, where did Visual Studio put my call stack? Maybe it's because I made the window so small. Okay, so I can see I'm in a function called isClosedFeature, and I'm trying to figure out where the call stack view is. Probably it's here. Let's click on that. Yeah, okay, there we go. Okay, so I'm going to, let's keep going, see where it is. Okay, so I just paused it again, and I can see where I am. So I'm in draw segment, which is, I know it's my street redrawing function. Okay, so I'll just hit continue again, I'll hit pause again. Okay, I'm in isClosedFeature, which is inside draw feature, which is inside draw all features. Okay, so that's drawing features. Pause it again. Okay, I'm inside draw feature again. Okay, and I'm again in this isClosedFeature. Do it again. Pause. I'm again inside feature, drawing features, and it isClosedFeature. So one thing I'm noticing is this kind of lines up with what I saw before. Most of the time when I stop this is drawing features. Something this one actually is get feature point from get isClosedFeature. I'm spending actually a lot of time figuring out is this a closed feature or not. So maybe I could actually store that in advanced, and maybe that'll be a bit faster. And so on. Okay. So, and I can even look at the variables here. So I can look at what is the feature ID. So if you have a function that takes a long time once in a while, but for most cases it doesn't, and some of our features are actually much bigger than others. One thing you'll find in certain maps like Iceland is we have some enormous polygons with like 50,000 points in them that are representing, say, the island of Iceland. They take a long time to render, which might give you some ideas about how to optimize them. So this technique can actually give you some extra information, not just what functions am I in, but even you can look at the variables to see is there a certain case where I'm really slow. Okay, so now I'm going to stop this and go back to slides. So it's really easy to do too. If you ever have a program that's unexpectedly super slow, you just do this a few times. If you've got an infinite loop or a really bad algorithm, you'll usually find it right away. Okay, so the last technique is to use an actual profiler. So you can compile with either release or profile. I'm going to compile with the profile, which turns off inlining. So program's a bit slower, it's a bit distorted in terms of its runtime, but I get more detailed information. I'll see information in every function. The easiest way to profile is to just use the exerciser. So the exerciser has a profile option in it. So I'm going to run the draw Toronto test, and I'm going to run it with my slowed down redraw. The reason is I actually want to spend most of my time in my redraw. I don't really care about load map and stuff right now, and I don't want to spend forever clicking. You can look inside the exerciser to see how this is done, but if you just run it this way, you'll get the profile information. What this does is basically, we're using a Linux tool called perf, which will interrupt your program 1,000 times a second and record where it is. Produces a really big data file, so don't profile forever. Like, don't just say, I'm going to profile this for the next 20 minutes because you'll fill your disk up. Profile it for 30 seconds or so, and then stop the program. You have this really big file in your mapper directory called perf.data, and you can visualize it with scripts we've written. So the script is called ece297 profile visualize, and it's going to show you what's in this file. And I already told you this. For a redraw function, it's actually useful to wrap a loop around it because I want to time my redraw function. I don't want to have I don't want to be dominated by load map. I don't want to go look at that. Okay, so what does this look like? This is the output of that ece297 profile visualize. Basically, all of the nodes, it's a graph. All the nodes, all these boxes are functions, and all the edges are relationships where one function called another. And the colors indicate the time spent. So red is a lot, green is a moderate amount, blue is not much. And it also, I'm going to zoom in a second, it also has written on it what percentage of time is spent in each function. Okay, so here's a piece, I'll try to demo this if we have time. But basically, the ece297 profile visualize, you can zoom in and out and so on. So you can do everything I'm showing here. So this is a routine in our unit tests. Well, draw Toronto is the name of the test, so name of the program. And the draw function is our main redraw function. And you can see that it says this function takes, well, there's two numbers here. The number in brackets is how much time does this function take. And this function takes virtually no time, 0%. It's because if you look at the code, our draw function is all helper functions. It doesn't do much of anything. But the time for this function and all the stuff it calls is a lot, 74%. And if you look at this, you'll see the rest is basically load map, which we don't care about. If we look at what does it call, this says, well, 50% of your total runtime is this draw routine calling the draw all features function. Okay, that draw all feature function itself only takes 0.7% of the time, but including the things it calls is 58%. And we can look down here and we can see it calls draw feature and it calls get feature type, and each of them takes some time. The other thing that takes some reasonable time is 15% of our time was drawing the streaks, which is draw all segments. Again, that function itself doesn't take much time, but its children do. And the main one that's taking, so basically we follow it down. We can see, okay, it calls something called draw segment and so on. And if you keep following, you'll see most of the times actually in the low-level drawing routines. Okay, and I guess I said all that. So that's one way to visualize. It's called the call graph. You can also use that same tool with this -t parameter, and it'll produce a different representation of the profiling data called a flame graph. So in this one, the width is proportional to how long you spent in every function. But you can't infer like sort of a sequence in which these things were called. It's just like the width means how long did I call this function. The stuff stacked on top of it is how long did I spend in his children. So you can zoom in on this a bit. So here I've zoomed in on it a bit. Well, I guess what does this say? Basically, these functions are like, why are we doing redraws? Like some zooms, some pans. I don't really care about that. But if I look here, I can see my redraw function calls draw all features, and this I can't see very well, but it's draw segments. So it gives the same information as the call graph, but in, I guess, a different and maybe slightly simplified form. Here I've double clicked on draw, and that means that I kind of zoom in on that and all the things that it calls. So this tells me that my draw routine, most of its time is spent in draw all features, which is the map features. Some is spent in draw the street segments. And I can go, well, where does that go? And this is actually kind of interesting. So it says that fill poly takes a fair amount of my time. This is closed feature that I kept showing up in takes a fair amount of time. And draw a line takes a long time. Draw a line actually takes the most. So what does this tell me? Well, it tells me I'm spending a surprising amount of time figuring out whether or not it's a closed feature. So maybe I could actually store that in advance because that never changes. So maybe I should store that in load map for every single feature. It also, you might think that it would take longer to draw all the polygon features, but it actually turns out that the line features, which are things like little rivers and streams, that's taking a long time. So this gives me maybe a hint. Maybe I shouldn't draw those most of the time because like maybe I should have a button to turn them on and off and so on, because maybe you don't need to see all the streams. And I'm actually spending a lot of my time drawing that. That doesn't seem like the most fundamental map information. Other than that, there's nothing that really stands out here of like I've got a big problem. Okay. And I think in the interest of time, I'm going to just skip the demo because the demo would basically show you me typing those commands and running those tools. But the files are big, so it takes like a minute for the visualizer to kick in and so on. Any questions on any of that? How many people are already starting to try to optimize their redraw speed? A lot? Okay, so I guess I'll give you a few hints based on what I just saw there. So features can take quite a while to draw. We have a lot of polygons, they're big. Also, you saw in Toronto, this is real data. We spent a long time drawing lines, which is like rivers and so on. So pay attention to that. Not all polygons are the same. Some maps have huge polygons, which can take a long time. And this is an advanced technique, but when you're zoomed way out, it's difficult to tell the difference between a polygon that has 50,000 points in it and one that has 500, right? If you sort of roughly follow the outline. So that's a technique that you could use to speed things up too. That is an advanced technique, but that's called sometimes MIP mapping, like having different levels of detail for something you're going to render based on how close in you are. And you also saw that as I zoomed in, our program slowed down by a factor of 10. So level of detail matters a lot, right? Like if you just draw tons of stuff, it's a lot harder to make it fast. So if you can be clever about what would a person really like to see, it can matter. There's also a comment in EasyGL about drawing lines, that when you draw lines of different widths, it's in pixels. And a lot of times you want thin lines. So that's 1 pixel wide. But there's a special line width called 0, which actually draws 1 pixel wide lines, but enables the renderer to take a few shortcuts. Doesn't worry about, is this pixel 49% on or 51% on? It's not very visual difference, but it's a lot faster. So if you're drawing thin lines, a line width of 0 is a good idea. So that's it for, I think, my tips on this. You can go a long way on making things faster. I would advise you not to go crazy. Because we don't expect you to go crazy unless you're just having tons of fun, okay? And that's it for today's tutorial. Any other questions? Okay, thanks everybody.